Welcome back, students. Today we would be learning how to solve this equation. Root of a positive root of b is equal to root of 2624, given that a and b are non-negative integers. So step 1, consider square root of a positive square root of b is equal to square root of 2624. So what I'm going to be doing is I'm going to be having root of a on the left, and I would be moving square root of b to the other side. So that would give me root of b. Now squaring both sides, we would get square root of a raised to the power 2 is equal to square root of 2624 negative square root of b raised to the power 2. Now, expanding the right side, this would give me 2624 negative 2 times root of 2624 times square root of b positive b. Of course, on the left, I have a. So, I've got 2624 and then I've got a positive b. I have got a quantity of this form, 2 times square root of 2624 times root of b. Now, on the left, a is an integer, right? Because from the question, a is given to be a non-negative integer. So, upon observation, clearly we know that a is a positive integer, b is a positive integer, 2624 is a positive integer, and 2 is a positive integer. Now, we are to decide what would be the state of square root of 2624 times root b. That's going to be square root of 2624b. Now, the only possibility for square root of 2624 times b to satisfy the left side is it should also be a positive integer. Now, the only way that square root of 2624 times b can be a positive integer if we have b to be a quantity such that which when placed here and the operation of root is applied, the output leads us to a positive integer. Now, if we were to simplify square root of 2624, then it can be rewritten as 64 times 41. Of course, b is there, so I'm placing b there. Now, this is nothing but square root of 64 times square root of 41 times b. Now, clearly, square root of 64 is going to be 8, and that is going to be 8 times root of 41b. Now, as I mentioned to you, our problem is reduced to 8 times square root of 41b. So, this has to be a positive integer. And that means when I apply the square root operation, the outcome should be a positive integer. And that is only possible, so I can state here. This implies that square root of 41b should result in a positive integer. Okay? And that is only possible. It is only possible if I have b as 41 times, say, some alpha squared. I don't know what this alpha squared is. And the same argument can also be repeated for a. A should also be some 41 times beta squared. So that when I substitute for a and b, I would be able to satisfy the given condition. So now what I'm going to do is I'm going to be considering the original equation, which is root of a added with root of b, which is equal to square root of 2624. Now let me substitute the value of a, which is 41 beta squared, added with the value of b, which is going to be 41 alpha squared, equal to I'm rewriting 2624 as 64 times 41. So this is going to be 8 times root of 41 on the right side. On the left side, it's going to be root of 41 times beta, positive root of 41 times alpha. Now, cancelling the square roots, we would be arriving at a result, or I would say at an equation, as alpha positive beta is equal to 8. Since alpha and beta are positive integers, clearly it's easy for us to determine the value of alpha and beta. So what I would do is alpha and beta sum should give me 8. Let me write it down here. If alpha is 0, beta should be 8. If alpha is 1, beta should be 7. If alpha is 2, beta is 6. Alpha is 3, beta is 5. Alpha is 4, beta is 4. Alpha is 5, beta is 3. Alpha is 6, beta is 2. Alpha is 7, beta is 1. So these are the possible values that alpha and beta can take. So therefore, the solution for this equation, which is root of a positive root of b, to be equal to root of 2624. The only possibility is these are the values that are to be assumed. In other words, if I were to take a to be as 41 beta squared, say I'm taking, for illustration purposes, I'm taking beta to be as 2. So this is going to be 41 times 2 squared, and b to be as 41 times 6 squared. So this is going to be 1624. So this is the value of a. And the value of b in this case is going to be 41 times 36. So if we were to multiply 41 times 36, I would get 6, 24, 3, and 12, 6, 7, 4, 1, 4, 7, 6. The value of b is 1476. So if I were to take root of a, which is 164, and root of b, which is 1476. So on the right side, it's going to be root of 2624. So as I mentioned to you earlier, this is nothing but, it's going to be root of 4 times root of 41, positive root of 41 times root of 36, and this is going to be root of 41 times square root of 64. So this is going to be 2, and this is going to be 6, and this is going to be 8. So the left hand side is equal to right hand side. So if you were to asked to indicate all the solutions, what you got to do is you got to take the values of alpha and beta and substitute it here and here and obtain the values of a and b. So I have just shown you for one value. So in this case, one of the solutions for this equation would be 164, 1476. So this is the solution set for this question.